Okay, Assalamu alaikum, everybody. Uh, Welcome to this fourth session on data wrangling, or you can say big data wrangling. Okay, so I have just uploaded some content for you, and I have given you the links for that. So today we are going to do some exercises again to develop the skill of wrangling, so you can understand what are the different operations that can be done during the wrangling phase. Okay. So in this case, if you click on this file sales data, so here we have the sales, around 8,400 rows. So it's a very simple, you can say it's a very simple data. There's not much to it. We just have the order date, the quantity that was ordered, and then we have the value of the sales. I don't think so that we have any missing values. Okay, Haris, I have muted you. Thanks. Okay, so I don't think so that we have any missing values here. So there are lots of analyses that can be extracted from this very simple data. So what you need to understand is that, I did explain to you about the concept of the probability distribution, right? So one of the things that we want to see here is obviously ये जो sales की value है. So what is the probability distribution of this column? So what is the most common probability distribution? Can anyone tell me?
Normal distribution.
Yeah, the normal distribution is the most common one. So we have to see whether this whole column of sales is following some normal distribution. So yeah. So you should actually make a note of what I'm saying. You can watch the video, inshallah, later on as well. So I'm going to tell you these different things that can be done. In any case, that's the first thing that probably you should see after filling in the missing values. So when you have filled up the missing values, then you should definitely check the KPIs or your more important columns, whether they are following the normal distribution, what sort of shape it is. For example, the shape could be right skewed, or it could be very much left skewed. I could have a very high peak like this one, or I could have a low peak like this one. So all of these are indications that it is normally distributed, but the skew is going to create some problems for you, especially when you do machine learning, or if you use this data even in business intelligence analysis. So you should be able to explain the skew, that why this skew is happening. Obviously, the skew happens because of outliers, or the skew happens because of the way the data occurs. So for example, if I tell you that the distribution of this column is like this, then what is your conclusion? Raza Bakir. What can you conclude about the sales?
That it's near the mean. A lot of the observations are near the mean.
Yeah, Kapil.
The few of the values are the outliers in the data. Some of the values of the cells are the outliers.
No, there is no outlier in this case. In this case, I told you that this curve actually represents the distribution of probabilities, or the probability density as it is called in the case of continuous variables. So I will call this as a density. If you were measuring an event like the roll of a dice, that would be a probability distribution function. When we have a continuous values of KPIs, then it is called a probability density function, or PDF. At each point, I can tell, for example, for a sales between $300 and $400. So if I find out the area under the curve, so it will tell me what is the probability that the sales lies between $300 and $400, something like that. So it's a probability density curve. It's going to tell you the probability. of a particular sale value. Typically, we do an integration between the point A and point B on this curve to understand that what is the probability that the value of sales lies between A and B. So the integral of this function is going to tell you that. Okay, but you will probably not calculate it unless you need it for some analysis. Okay, so that might be too complicated for you guys. But the main thing to understand is that if the curve goes like this, then that means ki the the values are very similar to each other and they're very close to each other. That's why they're having a very the range of probabilities is very much concentrated. So for example, this curve could be generated if all the values of sales are lying between, let's say, $300 and $330.
हाँ बोलो खोल तो दी भाई
I don't know whose mic is. So is this thing clear? This is telling you the probability, how the probabilities are distributed. So if I have a very long peak, what does that mean? G.
Outliers.
Not.
They show the outliers or.
No. This is not outlier. This basically means that, look, the curve represents the probability. It does not represent the sale. Do you get this?
Okay, all right.
Yes.
Yes.
So the curve represents the probability. So this sort of curve in which the peak is very high, that means that the values are not that many. The sale is occurring within a very short interval, and each of these values has a very high probability. You can see because the probability is 0 somewhere here, and very quickly the probability goes to a high value like 0.9 or 0.8, and similarly this all 0.9, 0.8, and it drops to 0 around here. So all most of the data which lies, it has a probability which is very high. So that means that the data is very much concentrated in a small range, and all the values have a very high probability. For example, if you get if everyone in your class gets a mark between 20 and 23 out of 30, then that value becomes highly probable because everyone seems to get the same marks. So it becomes highly probable because it has a higher frequency, right? If I have a curve like this, then what does this mean? Who can interpret this?
Many outliers.
You cannot look. You cannot always talk about outliers, right? Because outlier is a very strong term. Let's talk about the spread of the data. In the previous diagram, what was the spread? How was the spread of the data? Was the spread very small or very large? In the previous diagram, in which I drew this.
When in a short range, so that was giving us the information that most of the values having a higher probability. But in the second graph, there is a little bit higher spread. So the values having the probability will be smaller as compared to the previous graph.
No. I am simply asking about the spread of the data. How much the data is spread away from the mean. In this curve, in this probability density curve, is the spread of the data small or large?
The large.
No, I told you that
Small.
this curve is for values which are lying in a very small interval, like 300 to 320. So all the values of sales are very, very close to each other. And therefore, all the values that are occurring are very highly probable. So the spread is very small. The mean value could be 310 and the deviation of each value from the mean is very small. That's why we have a very long peak. Understand? Is it clear to everybody?
Yes, sir. I was also saying the same.
Yes.
Lower graph
So in this case, in this curve that we are looking for, the peak is very small and the tails are so long. So why are the
Yes,
tails
sir.
long? Because there are many values which have a very low probability because they don't have that much frequency. So the spread is very long. For example, the first sale can be 1 rupees, okay, and the highest sales can be 3 million rupees. And I can have many thousands of sales in between which don't have a high frequency. So this is going to stretch the probability density curve in both directions. Okay, so this could be the case when we have negative sales as well for some reason maybe. So it could draw a curve like this. But just to tell you that this sort of curve happens when the spread is more. And when you talk about outliers, so yes, there might be some cases that are outliers, but the normal curve is not the place to detect the outlier. The normal curve is going to tell you that probably there are outliers, probably there are no outliers. You will have to draw the box plot to understand that. Okay. So जब भी आपके पास data आए, आपका काम ये होगा कि सबसे पहले the first thing you need to do is to remove the columns that you do not want to in your analysis, either BI or machine learning. Definitely there will be columns which you will want to merge with each other. Definitely there will be columns which you might not want at all in your analysis. There might be some flags. There might be some columns which have a large number of missing values. So you will say, yaar, inko to phang do, just ignore these columns. There might also be some rows that you might not want. For example, there might be some customers you don't want to analyze. After you do all this cleaning, then you fill up the missing values. If you can fill them up in a reasonable way. After that, you start analyzing your numerical variables for things like this. Draw the normal plot, draw the box plot, and try to understand whether the curve is normally distributed or not. Box plot ke through you can realize the outliers that are potentially there. If there are many outliers, then obviously you have to do something about those outliers, because the outliers cases never go in machine learning. In BI analysis, you can include outliers, but in machine learning, it is better not to give outlier data because the frequency is not that much. Machine learning की requirement ये होती है कि machine learning wants data. So if something is not very frequent, then you should not give it to the machine learning model, but rather you should analyze that thing separately through some other statistical technique. Machine learning में वो चीज जाती है जो कि ज्यादातर occur करती है, which happens mostly. Okay. So these are the 3 or 4 things you should keep in mind, because I'm going to give you assignments from time to time. So you will have to develop your own strategies for wrangling the data. Okay, I hope that this is clear. So yeah, and the order quantity obviously is, we know that order quantity is correlated with sales, right? So I might want to analyze the order quantity and sales together in a BI scenario, but I might not want to analyze them in a machine learning scenario. In a machine learning scenario, I might just want to use the sales data and the date data, because I know that the order quantity is correlated with sales. The more the order quantity, the more will be the sales. Although it depends also on the product. But if I generalize, then I might say that, okay, if I want to forecast the sales. So for example, if I have time here and I have sales here and my sales is fluctuating like this, okay, and I'm asked to forecast what is going to happen in the next week. So I might, ask the system to generate the forecast, and it might tell me that this is going to be your sales for the next week. That's it. I don't want to use order quantity here. That's it. In a time series forecasting scenario, I might just say I don't want to use order quantity. In a machine learning scenario, I might want to use the order quantity along with the sales. It depends on how the algorithm is going to behave with your data, because it's never absolutely clear what the algorithm is going to do in machine learning. Okay, you can just do the experimentation and try to understand which algorithm is doing better for you. So wrangling has a big say in in data analysis. Okay, so this data seems pretty simple, and we're now going to see how we can understand it, wrangle it, etc., etc. So let me just okay, so we are here. So I have three examples of dealing with this sales data that we have just seen. Okay, so you are probably well versed now. I told you last time that pandas and numpy are the bread and butter of data wrangling. You definitely need to import these libraries because almost all the wrangling functions are within these two modules. Okay, so mostly we use just these, and if we want to write some code on our own, then we can do that as well. And then this is the library for visualization along with matplotlib. So these two are typically used for visualizing the data on different types of graphs, like the normal plot, line graph, scatter plot, box plot, etc., etc. So these libraries can help you, you know, uh, can help you visualize these plots in a better way. I can also draw the box plot and the other plots by using pandas. So I have multiple options for using for plotting the box plots. So it depends on what you want to use. Typically, Seaborn is pretty good because it has a good visualization effect. So you can use that. This is also some we typically include this statement because this allows us to program this API in line with the code. Import warnings we can ignore the one because typically the programming of the programming APIs of Python are getting updated. If you are using the functions of some outdated version, then it might generate some warnings. So you can suppress the warnings by this. Okay, so just let's execute this, and we just import the file. See the head. So you see, okay, now these things are pretty simple now. Head and tail, you should be able to feel comfortable about it. Most of you have submitted the assignment, so you should handle these things. So by default, it shows the first 5 values, and the tail is going to show you the first last 5 values. And this 0, 1, 2, 3, 4 is not part of the Excel file. This is in fact the index, because when you do the read CSV, then it imports the data in a data frame. Okay, so this is called a data frame. Data frame is a data structure in Python. Okay, just so just it is called a data frame. Okay, so this in fact this is your data frame, sales df. So this is the visualization of the data frame that is there. So most wrangling activities, we do exactly this. We import the data through pandas functions in a data frame, and then we can use this data frame to do the wrangling. Okay. So then you can also see the shapes and types, which is also typically what we are doing. So we have 8,400 rows and 4 columns, which we have already seen. And these are the types that are assigned. So serial number, we are not interested. Order date is an object. Obviously, we have to convert the object to a date time, because object simply means a string value or simply a Python generic object, which can be anything. But we have to specify to Python that this is a date column. So please convert that to a date column. Order quantity and sales, they have the right type. Okay. So now this is the function to convert. So I just sales df order date. I said to date time. So this is going to convert to date time. So now you can see now the order date has this date time 64 ns. This is the Python the Python type for date. So now your order date is being recognized as a date value. And what this means is that I can now apply many date functions. For example, I can extract the month of a date. I can extract the year of the date. I can extract the week number of the date. I can subtract the dates. I can add the dates. So I can, there are many functions of dates that I can use now on this order date column. So I'll just, so yeah, so now you can see, now it is showing here. You can see the order date is like this. And now the order date is being shown like this because now it has recognized it as its an officially date value. So now it is printing it like this. So the value is the same. It's probably 13th October 2010, which is the same value, but now it is written like what Python wants to see. Okay. And now this is what I was telling you about. Because now we have the date column in its proper format, which is the date time type. So now I can apply these functions to extract the different quantities. So what I do is that I'm making these columns: quarter, year, month, week, and day. And from each day, I can extract this. So the day is 13th, the month is 10th, okay? Year is 2010, the quarter is probably 3 because it is October. So it is probably the third quarter or the fourth quarter probably. And the day, the week number is according to that. So we have 52 weeks. So this is probably some 40th week or something like that. So this is very easy. So what we do is that on each column, on the same column of date, I do apply. And apply means that apply some function on the whole column. And I can write the function in one line. When I write the function in one line, I can use the lambda operator. And I'm saying lambda x, that give me lambda x. And what is lambda x? X is x dot quarter, because x is actually the date which is transferred to this column in lambda x. So what I'm saying is that order date is the column on which I have to apply a function, which is x. And what I'm doing is that I'm extracting the quarter from the date. So this is going to extract the quarter number from the date, and it's going to put it in a new column, which is called the quarter column. Okay. And similarly, I can use this built-in keywords, year, month, week, day, that I told you about this here, and extract the individual values and put them in relevant columns that I have named myself. So I can execute this, and then I can see what happens to the whole data frame. So now you can see that now I'm getting quarter, year, month, week, and day for each of the dates. So why I have done this? Because I might, in a BI tool, you will not want to do this, because a business intelligence tool is going to break down the date itself into its component parts. You can program it. But if you want to, if you want to use the quarter number in machine learning, or if you want to just analyze the dates in a BI tool, then you can even do this. It's very easy. It's just a few lines of code that you can copy and use anywhere you want. So now instead of, because the whole date is of no use to us, right? Because the whole date tells us nothing. It's just a combination of many different things. But when I talk about the year and the month separately, so now I'm going to see, I can analyze the sales across the months. So maybe I can detect a pattern with respect to months. Maybe I can detect some pattern with respect to the week. Maybe I can detect a pattern with respect to even day if I want. So that's why I have these individual values here. And in the companies, typically we have a quarterly analysis. So getting the quarter number is very important. So I can get the quarter number, and so this, you can see this for the for the next even 20 rows. So you can see it has extracted for each date. It has extracted this. So this is probably the April. April is the second quarter, and the fourth month, and it's the 15th week. In this case, it is the 41st week because we are in the second week of October, so it's the 41st week. Okay, so it's really interesting how we can use these values and how we can extract these values. Okay, so now we can print the date types again. So now you can see all of them together. So obviously these are all numbers, so they cannot be floating values, right? I can't have a floating quarter, I can't have a floating month. So all of these are integers. So what I do now is that, now it's up to you now how you want to analyze. This is one way of analyzing what you want to do, because currently I'm not using any BI tool, right? So this is one way of analyzing. What I do is that I map the quarter column to a type string, because I want to use that in a plot. Okay, so 1, 2, 3, 4 is not it's a numerical number, but basically it is a dimension across which I am analyzing my KPIs. So I can use that as a string. Okay, so so I cast the column as a string. So now you can see that the quarter is now an object, which is actually a string value. And now what I do is that I want to, the string value is 1, 2, 3, 4, right? These are the 4 string values for 4 quarters. But now 1, 2, 3, 4 is not very usable, right? So it is better to replace 1, 2, 3, 4 by Q1, Q2, Q3, Q4. So I just replace the value. So I say in this column, please replace the string 1 by Q1, in the same column 2 by Q2, in the same column 3 by Q3, and then 4 by Q4. Okay, so all the values of the string columns are now going to be replaced by their Q1, Q2, Q3, Q4 counterparts, instead of saying 1, 2, 3, 4, because that is not very convenient to show on charts. 1, 2, 3, 4. 1, 2, 3, 4 can be anything, right? It can just be a number. But when I say Q1, or you can even say, if you want, you can say quarter 1, quarter 2, to make it even better. So now you can see that it has mapped these values. Okay, so now I plotted, so I use the matplotlib to set a figure size. That means the height and the width of the figure. The DPI of the image that I should see, DPI is 100. And then I say SNS dot bar plot. So SNS is the SNS is the seaborn that I am using here. So I do the bar plot here. Sorry, where did it go? Yeah. So so what am I plotting here? We just need to understand that first. Okay. Sales DF, that is my data frame that I am working with right now. I'm using the group by function. So group by basically is used when we have multiple categorical values in a column, like we have quarter 1, quarter 2, quarter 3, quarter 4, and I want to find out the total sales across each quarter value. Okay, so what I'm saying is that group by quarter. Okay, group by quarter. And what do you want to group? I want to group sales dot sum dot values. So for the column sales, please sum up the values of this column for each quarter and show me in a bar plot. Okay, is that correct? So the Y of the bar plot is going to give me the total sales, and the x-axis is actually going to give me the index of this group by operator. Index is basically quarter 1, quarter 2, quarter 3, quarter 4. Because when I do the group by, then it creates a new data frame in which the index is the quarter 1, quarter 2, quarter 3, quarter 4, and the actual value is actually the sales that has been aggregated. So when you click here, so now you can see that this is the chart that you get. So this is a BI chart. So now we have aggregated the sales because we have 8,400 values of sales, but now they have been aggregated across these columns. So I think this is probably in millions. It has summed up across the millions. So you can change the size here. So you can make it even smaller. You can do 8.6. It's going to grow a bit smaller, or you can do 8.4 to make it even better. So now you can see it's quarter 1, quarter 2, quarter 3, quarter 4, or it's 2 to the power 6. So yeah, it's in millions. It's written 1E6. That means this value is in millions. So I'm getting this value in millions. So the highest sales are occurring for probably quarter 4, which is around 4 million, and the same thing for quarter 1, which is around 3.8 million. And the lowest sales are for quarter 2, and then obviously the quarter 3 is in between. Is this thing clear? So you can just use this code to do similar things for other data that I'm going to give you very soon. Okay. Similarly, but we can also do the same thing for order quantity. I can find out the total order quantity across the 4 quarters. I can just again try to just reduce the size a bit. So the order quantity per quarter remains almost the same. The total order quantity, the total number of items that have been ordered remains almost the same. So you can see that quarter 2 and quarter 3 have more number of orders comparatively as compared to quarter 1 and quarter 4. So apologies, I got disconnected. So I hope that everything is fine. So you can see that relatively quarter 2, quarter 3 have little bit less total sales, but little bit less. They have more orders, but relatively less sales. But the difference is not that much. It's 4 million and this is 3 point. Okay, the difference is great because there's a difference between 4 million and 3.5 million or 3.2 million. So yeah, so there's a difference. But this is just for the business managers. And what we are doing here is that we are seeing the average sales, okay, for each quarter. So the average sale is the average sale per quarter is 1750. हाँ, तो इसमें हमने किया ये कि we have drawn this line.
I'm sorry, sir.
Yeah.
सर आपकी आवाज काफी कट के आ रही है मेरे ख्याल में. आई डोंट नो, शायद मेरे पास आ रही है, सबके पास आ रही है.
नहीं कट रही है.
बहुत डिस्ट्रक्शन है बहुत.
बिल्कुल. अच्छा, 1 मिनट पे ठहरे मैं. Okay, so what we have done here is that I have drawn this line for the average of the column. So the average for the whole column is around $1,750 or Pakistani rupees, you can say, which is the average for the whole column, right? So we can see quarter 2, sorry, in the year. Okay, so now we are now plotting across the year. Sorry about that. So 2010 and 2011 is just below the average a bit, and 2012 is just on the average, and in 2009 we were doing pretty great. So it seems that the average sale is dropping down a bit, right, over the last 3 or 4 years. So it was right here, it was around 1900 rupees probably. And now we are down to 1750 rupees or something like that, or maybe it's 1800 rupees. So there's a difference. So I don't know how these values will be interpreted by each business because they understand their figures better. But these are some sort of wrangling steps that you can do to understand your data if there are no missing values. If there are missing values, then you first need to fill up the missing values, and then you can do things. So the first thing, get rid of those unnecessary columns, get rid of unnecessary rows, get rid of the missing values, and then you can start understanding the data through these things. Okay. We can also do this plot, which is giving you the total number of orders per year. So this is actually the mean, the average number of orders per year. So the average orders per year are. Sorry, is it again not clear? So here you can see the average number of orders per year, जो कि सारे columns से निकाले गए हैं, तो they are almost the same. So what we can conclude up to now that the average orders given per year are almost the same, and the average sale has dropped down a bit for the last 4 years. Across the quarters, we are doing pretty good in the fourth quarter and in the first quarter, but we are not doing that great in the second and third quarters relatively, because we have to understand that this sale is in millions, right? So it is a big deal to have a difference this much. अच्छा, आगे monthly average sale. So now these are the different months, right? So now we have plotted across the different months. आप इसको यहाँ से ले, क्योंकि हमने month का column अलग बना लिया है, so this is easy to plot now. So what do you see? How do you interpret this? कौन बताएगा?
Sir, these are
Maybe
different
basically
months, like
January,
one is
December.
January, 2 is February, 3 is March. The different
Remember
colors are
कि-
representing different columns.
Remember कि this is the chart which shows you the data for each month for all the 4 years, because we have 4 years in the data, 2009, 10, 11 and 12. So ये जो sale है 12 बार की जो sale है, that represents the sale in December for all the 4 years, the average sale for all the 4 years in December, right? So now interpret it. What do you see?
Summers में basically आपकी sales कम हो रही है compared to the other months.
So this is actually a drill down. This is actually a drill down of what you saw here. This thing, right? Because here it was only talking about the year on an average basis. And even here, you know, in the quarter one, it was good. Quarter two, quarter three, it went down. And then quarter four, it got up again. So the same pattern you can see here in drill down. So you can see exactly in which months it actually went down. So in May, the sale went down quite a lot.
Right.
May, June, July, August, that remains. This is the period that you want to analyze, and then you can decide to increase the sales of this period, because there's a dip here that we can see above as well. So this dip is here, is going back up again. The same dip you can see here, as which I showed you earlier on. This dip is here as well. Okay. So now this dip is actually a drill down. So इससे पता चल रहा है कि which months are better and which months are not good. So it seems कि you got good sales at the beginning. Basically, this is the winter season, right? So 12 and 1 mean the same thing. It's December and January is the winter season, right? So you have good sales in winter months, but you have horrible sales or bad sales in the summer months. So it seems that probably you are selling something which is just for the winter and not for the summer, or maybe you need to do something about your marketing strategies or etc. whatever. So similarly, you can see the total orders. The orders will remain the same as we saw in the quarter case. Almost similar. We got the maximum number of orders in May, and we got the worst sales average sale in May as well. So the season of the month of May is not great. And you can also see it at the weekly level, because we got 52 or 53 weeks in a year. So you can now drill down even further from the month to understand whether I can see some dip across the different months. Okay, so I mean, you can see the pattern is fluctuating here. So it's at the weekly level, it's almost the same. It's not that much different. Okay. So the weekly level is almost, you can say it's almost the same. Are you doing the same exercise side by side?
No, sir. We are just listening to you.
Then get the laptop, please.
Not now, yeah. Not now, sir.
आप लैपटॉप प्लीज कर लें इसको अभी खोले शाबाश साथ साथ करेंगे तो मजा आएगा ना.
Okay, sir. Just give us the 5 minutes so we can open
Okay.
the file. Okay.
Okay, I'll give you 5 minutes. I'm waiting. Okay.
Okay.
Okay, so in the same way, you can have this weekly number of orders analysis. It will take some time. So there is not much difference, but for the person who runs the business,
Sir,
these.
sir, there is a question from last graph, जो weekly वाला है, please. If
जी, please,
अगर आप,
please.
sir, this last 53rd week is showing extensively higher the sales, or what we call it. So is it a 54 or 53 combining 2 weeks, or it's just a single week?
No, this is the last week of December.
All right.
Yeah, this is the last week of December because this is the 53rd week, or this obviously this is this could. मतलब यही तो बात है ना कि यही these are the different trends that you can extract from such charts even before you start analyzing your data in BI charts or in machine learning. So you can extract this sort of information. So the people who are running the business will be able to understand these charts in a much better way, that how the sales are being done, And the overall conclusion is that the number of orders is almost the same throughout the year. There's not a very high level of difference because now we have drilled it down to the level of week, and we can see that the variation is not very high. Even in the May, June, July, August, even these months in which we have a problem of sales, the number of orders remains healthy. So the number of orders remains the same almost throughout the year, but in these 4 months of summer, the sales are going down. So that has to be determined, that why these sales are going down and why the sales are more in October and why they are less in summers for all the 4 years. I mean
It's a discount. Maybe there's a discount or something, because the number of sales is the same, number of orders is almost the same. That means they're selling the same amount, they're just charging maybe less or something.
Maybe there's a discount, maybe there's a promotion, but you don't run a promotion for 4 years, right? Maybe it has to do with the type of products that are being ordered. So even ऐसे products होंगे जिनकी value कम है, so even if they have a higher quantity, so their value, cost price or selling price is very small. Like maybe we have a soap, maybe we have matchboxes, maybe we have just chocolates and toffees or something like that. But we can't make assumptions until we really know what is happening. So when you do the analysis, so this is the first stage. The wrangling is the first stage that you need to do, and then you can try to understand this what is happening in your business. Okay. So there are no missing values we can see here, and now we can use this Dist plot. So Dist plot is the density plot that is basically the normal curve plot or an approximation of the normal curve. So here you can see that this is the distribution with respect to the order quantity. So the order quantity is all equiprobable. The probability of the order quantities remains almost the same because the order quantities are varying in a small range between 1 and probably 50. So the order quantity is not that much. So you can see here that the density remains almost the same. ये बात समझ में आई? Is this thing clear? This is exactly what I told you, that all the values are equiprobable because they lie in a small range. So the probability is linear here. It's almost a straight line. That means all the values of the orders are equiprobable. They have the same probability, which is around 0.02. Because that's what we concluded even from this case, that the order quantities are remaining almost the same, and from here we can see that they are varying in a small range. So people are going to order items either from 1 to 50, not more. If it was 5,000 or 5 lakh or 5 lakh quantity, or very less quantity like 1 or 2, then you can see that the probabilities will probably differ. But most probabilities are, all the probabilities of the values are equiprobable, because they're lying in a small range and all the values have almost equal probability. So this means that there is no biasness with respect to the order quantity. तो हम ये नहीं कह सकेंगे कि यार कुछ चीजें some things are being ordered very frequently, some things are being ordered very infrequently. So it has nothing to do with that. There's a uniform way of there's a uniform distribution of the number of orders that are placed by the customer in buying. Is this thing clear?
Yes, sir.
But when we see with respect to the sales, so now you can see that things are not very good. So who is going to explain me this chart?
The sale is increasing in particular months, as we saw in the chart.
All the values are basically low compared to, and only very few high values.
So this shows an outlier, I guess.
There are two things in this chart. The first thing is this long curve that is here, and the next thing is this long tail.
Yeah.
So what is the meaning of this? We just discussed this.
So all the values, most of the values are density populated between the
Red
0
is
and
large.
20,000.
Red is large.
So these pages
There are many sales which are concentrated in a very small area, which a very small range, and the probability of these sales values is very small, in fact varying between 0.00005, that means 0.005%, to there are many sales. We have 8400 sales, right? Because we have 8400 rows, so we have 8400 sales. Of these, there are many sales which are occurring in a very small area. Maybe they're occurring between 1 rupees to, let's say, 450 rupees. So yeah.
Yes, so
In fact, these sales are between 1 and let's say this finishes it here, so 20,000. So it's 10,000. So there are many sales which are occurring between 1 and 10K. Right?
the price of the product.
Yeah. The total sale. We're going to take a break for Maghrib later on, okay? Not right now. So is this thing clear? You can see the value here. Most of the sales are lying between 1 and 10K. And what about this long line? Who can tell me about this?
Sir, it means no sales happened
In between these
in that value.
numbers.
No, wrong.
These
There
are
is a
very
blue
low
line here.
probability.
When you see the blue
Sales-
line, yeah.
Sale is being
Its
occurred,
quantity
but
is very
quantity
limited
is
as
very low.
compared.
Yes. And what is the value of these sales?
4,000,
90,000.
50,000.
Between 20,000 and 80,000. Okay. I am having very small number of sales, but they have a very high value. मतलब 80,000 रुपए की सेल्स हुई है, 20,000 की सेल हुई है, 40 की हुई है, and maybe उसके बीच में भी sales हुई है. We don't know the exact values. We are just looking at the density plot. Okay. एक चीज जो something which happens very infrequently has a very low probability. Is that correct?
Yes.
Yes. So these sales values, which are very high sale values, they are not occurring very frequently. In fact, they're occurring only once or twice. That is why their probability is very low, close to 0. But What do we infer from this? From a business perspective, is this thing useful for us or not, this long tail?
Very useful.
Not
Yes, sir.
very
I
useful.
think it's useful because some products are selling at very high rate and some products are selling, but they are more profitable products.
But these aren't reliable sales, right? Because they're not happening at a high frequency. So we have to take it, look at the high density values.
Sir, we should
That is both the things are correct. Absolutely right that this is the part which is more reliable for us, because it is representing the majority of sales that is happening between $1 and $10,000, or one rupees and 10,000 rupees. But still, this skew that is here, that is called a skew, right? So ये जो skew आ रहा है, this is good for us because the sales value is very high, so it is giving us a lot of profit, right? So from this chart, I can actually understand. I can analyze both of these different types of sales separately. So I can extract these sales values which are more than 20,000 and see इसमें कौन सा product बिका है, which product has been sold in these sales, and analyze them separately, make their own separate group and analyze them separately in a BI tool or just on Python. And I can analyze these sales separately. The point is that if I want to use the sales values in a machine learning model, so I will probably give it the sales value for this range. Okay, because I want to give the data which is frequent and more reliable so that the model can be trained in a better way. But from a perspective of the business intelligence tools, I will give it everything so I can analyze them together in the BI tool as well. Is everything okay?
Yes.
अच्छा, अब इस चीज को मजीद समझने के लिए, to understand this better, we also draw the box plot which I told you earlier on. Okay, so this pattern that we're looking here, ये जो pattern यहाँ पे नजर आ रहा है आपको, this pattern will become more clear when we draw the box plot. Okay, so now when I draw the box plot, so now you can see ke, so let me just so it won't be visible that way. We'll have to browse it. So please fine. अच्छा वो inline आ रहा है ना असल में, चले. So let's just put it here. Yeah, so now it is clear. So now you can see what is happening here. No, this is not even 10,000 that I was looking at. No, this blue area represents the just wait please.
Some video. Thank you.
Okay, so what I'm trying to stress here is that this blue area that you're looking at, this blue box, is actually equivalent to this long peak that you're looking at. So that is where your most of the values are concentrated. So they are lying only between 0 and not even 10,000, is probably just 3,000. So most of the sales that are occurring is between 0 and 3,000 rupees. And you can say that the reliable range of sales is from 0 to this value, which is, let's say, I think it's just 5,000 rupees. It's just 5K. Okay. And now you will ask me, what is this huge tail here? So that is called a box and whisker plot. So this is called a whisker. Okay, इसको whisker कहा जाता है. There are no whiskers on the left side because we don't have negative values. Just starting from 0. We have a large concentration of values between 0 and 3,000 rupees. And then we have a safe P range till 5K. So most of the sales are occurring between 0 and 5K. And then we have this long whisker of values all the way up to, let's say, this point, which is approximately 32,000 rupees. So, but even I'm not comfortable with this because ideally the box plot is like this. If you can try to understand this, now. So the box plot ideal is like this. This is a pretty healthy box, and then we have some whiskers of the same length almost here. So this is a good box plot to have. This box plot basically means that there's a lot of skew in your scales towards the right hand side. These 4 points are definitely outliers, but they're outliers with respect to the definition of the SNS box plot implementation. So this is the point which SNS believes is the normal, is the point in below which everything is safe, and after which you can say that things are outliers. So we have 4 huge outliers. You see, one of the sales is like almost 90,000 rupees, and then one sales is like maybe 50,000 rupees or maybe 45,000 rupees, and then one sale is like 40,000 rupees, and the other is 33,000 rupees or something like that. So these 4 values are skewing, especially this value is too high, and it is skewing everything. So there are no sales in between actually. So there's just this one value which is creating this long tail here. So there's just one value which is around 90,000 rupees. And then below that, we just have 45,000 rupees. So there's a lot of difference between these two. But the point is that this 90,000 is creating a long tail in the normal curve and the density curve that we have. And it is also skewing everything which is here. So what we can do is that we can try to remove this from the data frame and then draw the box plot. So you will see that box plot is going to adjust itself accordingly. अगर मैं ये outlier हटा देता हूँ तो जाहिर सी बात है ये थोड़ा सा बड़ा हो जाएगा और ये थोड़ा सा skew right का कम हो जाएगा क्योंकि ये 3 points फिर यहाँ चले जाएंगे and this is going to spread out a bit. Is this thing clear? Okay, so now looking at these charts,
Sir,
can
you show us by increasing the outliers so we can know what are you talking about?
What am I talking about?
Sir, you
what
said
does that mean?
If you can increase the outliers, then the means the size of the chart.
ये देखिए इसमें what we have done is we have drawn the 32,000 limit ourselves because that's our own understanding. So we draw this AXV line on this. So I'm sorry I mentioned that this is according to the box plot, but we drew this ourselves because of the fact that these values are all concentrated together. So I consider them as part of the data which is normally or regularly there. And these 4 values are looking like outliers to me because of the fact that they are far apart from each other. They are separate from each other. They are not concentrated. So they are not the regular data. You know, if I'm getting data which is frequent, which I can see on this line, then that means you can consider that as the regular data. So regularly my sales are varying between 0 and 32,000 rupees.
Okay, sir.
So
I understood.
If I can, let's create a new data frame in which I just simply select all those rows in which I have sales less than 32,000 and I put them in a filtered data frame. Okay. So in other words, I remove the outliers. I create a new data frame in which I do not have these 4 values. I just have these values, these values. So now when I plot the density curve, so you can see it is much better now. It is much better now, but still the problem is that even this is sort of a skew. I can't consider that as the normally distributed or reliable area. This is also a skew, but it is that what I'm getting right now is much better than what I was getting above. Like see this chart, okay, and now see this. So this is much better. You know, the curve came down, the peak came down. I can see यहाँ पे थोड़ा सा spread इसका ज़्यादा हुआ है. So this thing is a bit better, okay. And now the box plot also is a bit better. It's not that much skewed. So इस तरह की चीज है, ठीक है. Now where do you draw the line? Where do you say that this is out? Some of you might say, I think that this is the place जिसके बाद outliers आते हैं. Some of you might say, नहीं, ये हमारा reliable है, इसके बाद 5,000 के बाद सारे outliers हैं. Someone might say, no, 10,000 के बाद 10 outliers हैं. So it depends on you. हमने कहा कि 32,000, You can select your own value and do your own analysis to understand what is the best shape for the box plot. Just what is the best the threshold जिसके नीचे मेरा सब कुछ reliable है, जिसके आगे सारे outliers हैं. So that depends on you. So when you do the जब आप वो करते हैं ना कि clustering जब आप करते हैं, when you do the clustering, तो clustering के अंदर ये चीज होती है कि you can cluster your sales according to these outliers. You can say कि this is my cluster outlier, this is my cluster of outliers, and this is my cluster of regular data. अगर आपको इस तरह का करना है तो आप कर लें, क्योंकि जब भी चीजें ज्यादा हों तो उनको समझने के लिए आप क्लस्टरिंग करते हैं. ठीक है, तो क्लस्टरिंग भी ईडीए का हिस्सा है, वो भी हम इंशाल्लाह ताला करेंगे. अभी फिलहाल हम उस पर नहीं जा रहे. अच्छा, अब so is this thing clear now?
Yes, sir. Sir, can we take the break?
Just after 5 minutes, if you are.
Yeah, yes, sir. I'm okay with that.
Okay. अच्छा, अब दूसरा जो है ना, तो now this thing has been pretty useful for you कि अब आपको पता चल गया है कि what is a normal curve, what do you mean by density, what is a histogram. So this is a histogram. Histogram के ऊपर you draw this normal curve. What is a box plot, how to interpret for outliers. So you know all these things now. Okay, you know also how to do this group by to understand different things, across the different months or across different products. So on the x-axis you can have different product names as well, and for each product name you can see the sales. So there's a lot of things you can do with this order. Okay, so now I will just show you one other file. Yeah, so this is the order data. So just let me. I think most of these are been taken from Kaggle. So now these are order ID, then the customer who gave the order, and the status of the order. So status is something जिसके cross आप वो KPI वगैरह देख सकते हैं, but we don't have any KPI here. We just have the dates. Okay, in this particular. So you can see the filter here that probably we have delivered and we have invoiced and blah blah blah. But what we are recording here mainly is we are recording some dates here. Order purchase timestamp, like it's 2nd of February, 10:56. Order approved after a few minutes. Okay. Order delivered to the carrier, which is 4th of. So this is sorry. So October. This is 2nd of October, 2017. It was approved after some time, after a few minutes, and it was delivered on 4th of October to the carrier. To the carrier, in fact, who is going to give it to the customer after 2 days. And it was delivered to the customer on 10th of October. That means even after 6 days. So he gave the order on 2nd of October and he received it on 10th of October. That means after 8 days. And we also have an estimated delivery date. So the estimated delivery, sorry about that. The estimated delivery date was 18th of October. But the customer was delivered the parcel on 10th of October. So that's pretty good. Okay. So similarly, we are recording these 5 dates for each customer, for each order that is given by a particular customer. We are not giving you the customer ID because it is all anonymous. So the problem that we have to solve is that we have to find out the orders that are getting delayed. Okay, we have to find out, we have to wrangle the data to understand how many orders are getting delayed, and how many orders are on time, how many orders are getting delayed. Delayed obviously means that the delivery date is more than the estimated date, right? Because I estimate the delivery on 18th of October, but I'm delivering on 24th of October, so I'm getting late. So then that is a delay of 6 days that I am generating. In this case, the delay is in minus. So in this case, the delay is actually -8 because I delivered 8 days before the estimated delivery date. Is this thing clear? Haji?
Yes, sir.
Yes, sir. So now what we have to solve here is that, so I import this data and let's see what is the shape, etc. So we have around 99,000 or 1 lakh rows over 8 columns that we have already seen, and all of them are objects. So obviously, first of all, we have to we can just see the head here, so it's pretty good in the data frame. So first of all, we rename the columns to make it better, like purchased at, approved at, delivered to carrier on, delivered to customer on, estimated delivery on. So I just make the column names more more usable. And then what we do is that we are just, because we don't care about this order status and customer ID, because we are just concerned with these dates. We have to work with dates. So I just sample these dates from the orders DF and put that in orders DF. So I'm just concerned about the date. I don't want the other columns. Okay, so I make this as my data frame. So this is the double square bracket from which I can do that. And then obviously I have to convert every date to date time. So let's do that. We have already done that. So I do that. It's already converted to date time. So I can see the head now. So you can see now the dates are very different from what we are looking at here. So they're not different. I probably recognize. In any case, it is now converted to the format. So what is the shape of this? The shape is almost the same. Let's see the null values. Okay, so we have these null values. Currently, abhi jo मामला है ना वो, because do you think it is possible to fill in the date values? If the date values are missing, can we assume and fill in some date there? Will it be an intelligent thing to do?
No, sir.
No, sir.
Yeah, we can't do it. So it's better to do drop NA. Drop NA basically means that drop all the rows in which we have a missing value. Jis row mein bhi value missing hai, us row ko drop kar do. So that's what we do, because we can't do anything about this. We can't. How can we fill up 3,000 missing values of dates? I can't even fill up 160 missing values of dates. How can I assume the date? Unless I have some previous knowledge, some business knowledge. So if the business is going to tell me that you can fill up the missing values in this way, then okay, you can fill up. Otherwise, you cannot. Okay? You have to delete those rows in which the date is missing. So okay, so now let's take the break now, okay? Sahi hai? Okay, so Bismillahirrahmanirrahim. Let's start again. So we dropped these rows in which we have the missing values, and I think no matter what type of business data you have, you cannot fill in the missing values for dates unless it is the business can give you some value. Otherwise, you just have to delete those rows, because we cannot assume the dates by ourselves. Okay. If the year is missing, then obviously you can assume the year. You can also assume the quarter probably, but not the whole date. Okay, so now we are finding the difference between the date at which the order was approved and on which it was purchased. So this difference is obviously not going to be that much, because we have seen this might be just several minutes or several hours maybe between the approval of the order. So let's see how much that is. So I just create this variable, okay, in which we calculate this date, and now we convert this date to hours. So we divide this by 3600. So whenever you want to apply one function on a single column, you can use the lambda. So lambda function is just a function in one line. You don't need to create that function over multiple lines. So probably you know about this. So dot apply is the code that I told you above. So in any case, so let's execute this. And what is the mean value? So the mean time to approve the orders is 10.3 hours. So I think that is pretty reasonable, right? 10.3 hours is a pretty reasonable time. So we can just plot this, the distribution plot for this. And oh, so what does this mean? Can anyone tell me? Hey, Haris Bilal, what does this chart represent? This is the chart for the difference between the time when we gave the order and when the order was approved. So the mean time is 10 hours. But
Sir, yes. So the time between the order and the approval of the order is very, मैं कैसे बोलूं कि बहुत पास है उनका टाइम, मतलब कि किसी ने ऑर्डर किया उसका ऑर्डर अप्रूव कर दिया था.
Yes, obviously, that is true that many values are just concentrated and that is the reasonable range. But we have a very long tail here. What does that mean? Arib?
It means, sir, it means that we had like few orders which took so many hours,
Yeah,
and like they can be something which has to be taken care of.
exactly. So these are the orders which took so many hours. You can see that. So typically it is just between 0 and 10 hours. And that is the average time as well. We are getting 10 hours. But as in the previous case we saw earlier, we have this long line. Okay, we can say that chalo yaar ye bhi reasonable cheez hai, isko bhi jaane dete hain. But these three values are really disturbing, no? So we have an order which took 400 hours, another which one took around 550 hours, and this one took more than 700 hours. So these are definitely outliers which are skewing the whole distribution. And uh, even I think we can put the line somewhere here, right? I guess ideally speaking, this is the time. I mean, when you give an online order, it just gets approved within a few hours. So one point of view is that all of these are outliers. So we can consider all of these together, but more specifically, these are the three which are more, they are creating more disturbance here. So let's see. So if we can just, sort the values in the way ascending. So ascending sort means that from the smallest to the largest. And we just filter the values. Just so we have sorted this column, which is the between orders approval. We have sorted that in descending order, and we are ignoring the first four values, which are basically the outlier values. So now let's see what happens here in the new one. So it's a bit better, but it's a bit better, but even the box plot will be a bit better, but still वही वाली बात है जो पिछले केस में थी कि the outliers are, it just keeps on getting, although the size of the box is now better. That's what we wanted, कि box का size थोड़ा सा अच्छा होना चाहिए. So it really depends, so it depends on how you see things, right? So someone might say, yeah, this is fine, yeah, this is okay. So 300 hours is not bad, it's okay. Someone might say, no, yaar, 50 ghante hona chahiye, we can't have more than 50 hours. So it really depends on your business, okay? And now we come to the real thing, which is the time between, estimated delivery and the delivered to customer that I was talking about. So this is the actual difference that we want to work on. And I just convert that to hours. So that is basically, and that's we can find out the, अच्छा ये भी इसमें होता है dot mean. Dot mean is also there, which basically gives you the mean of the column, okay? In a pandas, in the pandas case. So the mean is, what is the mean? Minus 268 hours. What does that mean? Gee, Daniel, what does this mean? Minus 268 hours.
That means basically it takes 256 hours, the difference between the two values.
Sir, it basically means that the most of the order were like dispatched 268 hours before the estimated time.
Yeah, 268 hours. How many days will that make?
It's like 10 days, 12 days.
Yeah, around 12 days. So that means around 10 days or 12 days we are in advance.
10.6.
Sorry?
10.6.
Yeah, 10.6. So that's okay. So we're on the average, we're doing pretty good, but we have to look for the outliers. So let's plot this. Let me see if we have outliers. Oh, so this is pretty normal, right? Now, for the first time, we have seen a curve which seems pretty normal. Why are we having values? Can anyone tell me why we are having values here? Why we are having this negative tail?
So late dispatch maybe.
No, that the deliveries which arrived on time. Yeah, the deliveries which arrived on time. And what about
Sir,
this?
mine, which were delivered after the estimated time.
Yeah, so we have to look at these one, which are actually what we want to focus on, right? So what are we doing here? We sort in a descending order and we put that. So we got 50 values in which we have the time difference greater than 2000 hours. So इसका मतलब basically ये है कि from this point to this point I got 50 values. I mean 50 orders which are taking more than 2000 hours of delay, being delayed by 2000 hours. We have around 50 hours, 50 orders like that. 80 days late. So 2000 hours is like 80 days. So we have 50 orders which were delivered 80 days late. And we have 800 orders that were delivered at least 20 days late, which is this one basically. So in what can you conclude from these two statements? "20 days late and we have 800 orders." That's quite a lot. Something is wrong. What do you think? Huh? Yeah, so this is something is obviously this is true that obviously that if the number of days is increasing, I'm not going to have too many orders. So I will have probably just one order which is delayed by 500 days, something like that. If these days are less, obviously I'm going to have more orders which are delayed like 1 day or 2 days, but still 800 is too much. And there were 6,500 orders that are delivered at least 1 day late. They are greater than 24 hours, delayed by 24 hours. So that is 6,500 orders. So that is not good. This is not a good performance because a delay is a delay. 1 day of delay means the customer is probably not will be happy over this. So around 8,000 orders were delivered at time. Most of the orders were delivered on time. So 92% orders are delivered on time, okay? Because we are just dividing this by the shape 0. Shape 0 is the number of rows in the time difference, okay? So now when we, yeah, so these are 8,000 and when we just, so between estimated actual, have we messed with that? So yeah, so this is the same as the original one. So we're actually, in this case, we're doing the analysis to understand the things, what is happening here. So some of the orders are being delayed by a large amount. Like in this case, we have 50 orders that were delayed at least 80 days late. Then we have 800 orders. And then we have these 6,500 orders that were delivered at least 1 day late. So I think we need to, we can extract these orders and we can try to see कि ये किस चीज के orders थे, who ordered them, what was ordered, why was it delayed. So when you have detailed data about the logistics, then you can try to discover then why the delay is occurring. But right now we can just do the analysis at this point. This is pretty normal. This is pretty good. But we would remember this, we would always like the size of this box to be bigger. So if the box was like this, then it would have been pretty good. Okay, but the box is very less, and that means there are lots of different patterns going on inside. The more the diversity, the longer the line, the whisker, the more it means you have different outliers and different patterns in your data. So probably you need to set some sort of a threshold to have a balanced box plot. It depends on how you see it. I mean, I can't force anyone to think in a particular way. It really depends on what you see. And now we are finding the difference between when the order was approved and when it was delivered to customer. So this is the actual time it takes to process the order. So the mean time is actually 291 hours or 300 hours, you can say. Something like that. So this is pretty good. So we are having a, so in again we are having a few outliers here, but you can see that the normal curve is pretty good as compared to the previous cases. And when we see the box plot, so this is pretty balanced as compared to the previous cases. Although there are still outliers here. So for some cases it is taking more than 3,000 hours or 4,000 hours, and that is not good. You know, that means a lot of delays occurring, which we are not in a position to agree to that. So we'll have to do something about those cases, and we have to dig deep and see why the delay is happening. So when I filter it with respect to 3,800, I can just see that, you know, the box plot is now much better. Purchased and delivered, so we can again take that difference as well. So that is 301 hours. On the average, it takes 12 days to deliver the order. So this is the Dist plot. So this is also pretty healthy. And between purchase delivery, so let's see the box plot. So this is much better than the previous ones. And when we sort, so greater than 1,000 hours, I have 1,500 orders took more than 40 days to deliver, and 13 orders were delivered within a day. So, you know, all of these different types of analyses are there to actually help us understand different types of things about the data. So all of this is in fact the wrangling that we are doing here. You have to understand that this is actually wrangling. So we did a lot of things in this file. I mean, we imported the data, we saw the types, we saw there were no missing values in the first data, we typecasted, you know, and then we did all this we got these basic graphs in place. We made some conclusions about the summer month. The sales are going down in summer month, and we saw the weekly and the monthly and the quarterly sales, and we saw the distribution of sales. We figured out that there are almost always outlier cases that we have to consider separately. So we draw both the Dist plot and we draw the box plot through SNS to understand where to do the cutoffs, where to find the threshold, and then we make our conclusions. So this is just playing with your data. You can play more and more and more, and then you can try to understand how things are happening here. Is this thing okay? Any point that you want to understand here? जी कहाँ रह गए सारे?
Yes, sir, got it.
ठीक है, सही है. Acha, what I've done here is that I also have this other file. So in this, we have also tried to, do the same things. I will just browse through this quickly. So this is not that much sophisticated as the previous one. So just execute. So it's the same thing. I don't want to see the head. So this is for the order, in fact. So is we are just typecasting here. I think it's that much is यहाँ तक थोड़ा same है. Now finding the difference. I find out the total seconds. So 268. So we have written what जो चीज समझ में आ रही है हमने यहाँ पे लिख दिया है. So it's the same thing, 291 and 261. So some people will just create a new data frame for everything. So we can create a new data frame in which we can, calculate this time difference. So when you calculate time difference, you can cast it as a new data frame because it will allow you to do some calculations. So in this case, what we have done is that we have print out the percentage of rows in which the time difference is greater than 5 minutes, 10 minutes, 50 minutes, 90 minutes. This is another way of seeing the same thing that we were looking at in the previous file through box plots and Dist plots. I think what we saw here is a more sophisticated approach as compared to this one, but everyone has his or her own way of analysis. So this is also one other way to do it. So I'm just counting the rows in which the time delay is more than 5 days, 10 days, 50 days, and 90 days. So 10%, 30%, 28, 4%, in 1% rows, we have a delay of more than 90 days. So this is the .hist function. That this is not from SNS. This is the histogram from the pandas. So when I can write the name of the column .hist and it's going to dot the histogram for that column. Obviously, the histogram is going to be like this because there are very few skews. So now this is unsophisticated. For the first 100 rows, it's like that. I can also draw the box plot, but it's better to use the SNS box plot. It is much better to see. You can realize that now. So now, but what we have done here is that we are looking at individual rows separately. We are plotting out different values and seeing कि कितनी values हैं जो कि इसको satisfy कर ली हैं जिसमें time difference is greater than 1,000 hours. So I don't think so that this is a good way to see it. It's better to draw the box plot and then draw the thresholds that we have already seen. In this case, the box plot is not very interactive as the SNS one, so you can use that. So here we are doing exactly that. We are trying out different thresholds and seeing the shape of the box plot. कि किससे box plot की shape थोड़ा बेहतर हो रही है. We are trying different cutoffs and see कि कहाँ तक हमने काटना है, where we have to cut it. ठीक है. So here we have this time difference with the difference less than 0.41 and greater than 0. So this is the best graph that you can have for this time difference. 0.4 hours is the time taken to deliver. Okay, but obviously we have to look at the outliers as well. We can't just have this. This is not what we want, because so let's see what the count. So there are 53,000 rows here. No, 5,300 something. That's 53,000. So out of 89,000 rows or 1 lakh rows, there are 50% orders, or almost 50% orders that are being delivered on time. Okay, so let us see कि ये difference कौन सा निकाला हुआ है. Let me see this. So it's between order approval. So it's the between order approval, when it was approved and when it was delivered. So it's how the process is taking place. And the estimated, we have already seen that this is okay, but we need to dig this as well as we did in the previous file. This is the main thing that we want to see. And this is also the order approval. So things are okay, but the ideal is it's being delivered within 0.4 hours. The shape of the box plot is good, but our aim is not to make the shape of the box plot good. Our aim is to understand what the data is telling us. Okay. And similarly here also we can just I just execute run the selected cells. I can just import this. So the same thing. I just cast the order date, and I can find out the quarters, etc. Everything here. I can map the sales quarter as that. So this is exactly like data warehousing. So in the first file, we were using the group by, but you can also use a pivot table to do the same thing. So this is pivoted, this is printing out the actual values, and this is pivoted with respect to the total sales. Again, this is 1 to the power 6. Okay. So we don't want to see the column. So I can pivot with respect to the year as well. This we have already done, but in the previous case, it is done in a good way. A pivot table is actually a very useful data structure for visualizing these sort of aggregations. So we can draw different pivot tables, or you can simply use the group by to understand. Okay. Okay. So this is not very interactive. You can see this is not looking good. So in this case, you should remove the label, just increase the size of the box plot. So increase the size of the plot so that it becomes clear. And now we are back to this date manipulation. Okay, so just this one. So I guess the results will be the same because yeah, we are just here we are just casting the dates. So now you're pretty good hands-on with this, that what we need to do. And we are finding the difference between approved ad and purchased ad. Okay, so this is the first 10 we have to do. This is again 10 hours, and then the other one is actually estimated delivery. 291 that we have already seen. We cast that as a time series, and then we make a new data frame. But I don't want to see the head of that. So this is pretty similar to the last file, 28, 30 exact. Just draw the histogram. So now we come to this. I can import this. So let us draw the box plots. For the time difference, the box plot is worst. In this case, I don't know why it is worst. So this one is good, but I think we just okay for time difference less than 1000 for processing the orders. It is like this, and for the case of less than 350, the box plot is going to be even better. Obviously, jitna piche aap cut off lete aayenge, the better it is going to get. Okay. So I think there's some error here in the code. So we can't have things like this in which we are specifying the exact index of the rows to find out ki kaun sa hai. We can't have something like this. We must find out a more tangible way of programming this. So here what we have done is that we have tried to find out, again, we are trying out different thresholds, but this is either, I don't think this is the way. We are trying to make the box plot better and better and better. So that's it. So I guess it's a good hands-on practice that you can have. I'll encourage you to repeat these activities at your home after you have done here after the class. So I'm going to first show you the missing value data. Let me first open the file here. Yeah, so let me just yeah, so here we have the missing value data. I have uploaded all the files. So what we have here is we have the customer. Yeah, I don't know how many rows we have here. So we got just 28 rows. So this is, we are playing with missing values. So we have the customer ID. So we have one ID, customer ID, which is missing here. We have the names of the customers. We have missing values here as well. We have the customer age. Again, we have missing values. We do not have any missing values in the date column. We have missing values in the product and the quantity and the sales. So lots and lots of missing values. Actually, I created this file to tell you how to, to say how to deal with this situation, because typically you are going to have such a situation in your normal business file. So let's see how we deal with this. Okay. So the first one is okay. Let us import this, and I read the CSV file. And what we want, if you want to delete rows for say customer name, yeah, so we remove those rows in which the customer name is not present because of the fact that probably I cannot assume a missing value for a customer name according to one type of thought process. Okay, so someone might think that okay, this is मतलब you have to understand one thing, I can replace the names here by looking at the values of the other columns, which is what I explained to you, I think, last time. So I have two people who are missing here. Okay. But what I can do is that I can monitor the dates and the product and the quantity and the sales and see what is more, which type of data is more similar to this, and then replace the customer by that name. So maybe there's some other person who has done exactly the same and we can replace that by the name. But again, that will be an assumption, right? That will be an assumption. It depends on how you tackle the situation, not according to how I am thinking. In any case, the first thing that we think is that we have this, we can choose to just delete those rows in which the customer name is not present. Okay. So it's just working, just wait. Okay, so you can see when I print the total number of missing values, so we have a customer name is 0 here because I deleted those rows in which the customer name is not present. I don't want to fill up the missing values by taking any assumptions. Okay. Other than that, I have 3 missings in age, 2 missings in product board, 6 here and 7 here. Okay, so one of the ways that we can do it is we can use the imputer, and we know what impute means now. So we do a copy of the current data frame and we create this new one in which we are imputing by the mean. I can use this simple imputer and I can say the strategy is mean. So just replace it by the mean. And I say, okay, jo values customer age mein, sales mein, quantity mein missing hain, all the missing values in these 3 columns should be simply replaced by their mean values. Okay, so this is one way to do it. So you can look at the code and use it for your own benefit. So now you see it's just product board which is left. Product board mein to zahir si baat hai, it's a string value. I can't replace that by a mean. It does not have any mean. So now when I plot sales versus quantity, what does this mean? Remember that we have plotted this with respect to the missing DF, जिसमें हमने values replace कर दी हैं. So can anyone interpret this chart for me, please? G. Okay, so you can interpret it like this: when the sales are increasing, what is happening to the quantity? What will we expect?
So I think it's decreasing.
Quantity is decreasing.
So let us do one thing. Let's do the other way around. Now what do you see? Ji, Banish.
Yes, sir.
Kindly interpret this.
सर जैसे जैसे क्वांटिटी बढ़ रही है, सेल्स उस तरह से नहीं बढ़ रही है.
So that's okay, but again, what about something more concrete?
सर जो क्वांटिटी बिटवीन 1 and 2 है, सेल ज्यादातर उसी के अंदर है.
सेल्स की जो अमाउंट की बात करें ना कि how much sales has occurred, let's talk about that because we're interested in the profit. How much sales has occurred, that is more interesting for us, right?
सर सेल्स अप टू 10,000. सर मोस्टली क्वांटिटीज जो है ना वो 10,000 सेल्स के बिटवीन है. 10,000 एंड 5 नहीं 5 2 to
नहीं
10,000.
भाई, नहीं, we have to see what are the higher sales and what are the lower sales. We have sales which are greater than 40,000 rupees, greater than 30,000 rupees. These are outlier sales probably. If you draw the box plot of sales, you will see that these are outlier sales, right? But this is good for us. So we are just one product, which is being bought in one quantity, just one product, but it is giving us lots and lots of sales. We have had 3 such sales, right? These 3 sales are outlier sales probably, or these are the sales जो कि normally हमारा distributed, which are forming the box and which are forming the main part of the normal curve, I guess. And this one is an outlier.
सर से मोस्टली इंडिकेटर है कि जो हमारे महंगे प्रोडक्ट्स हैं, ये लीस्ट एक्सपेंसिव प्रोडक्ट है, उनकी सेल्स ज़्यादा है, और जो हाई एंड प्रोडक्ट है उनकी सेल्स बहुत कम है.
The high end, we have no knowledge about high end or low end products. All we know is that we have had 3 sales which are very high sales, and in which just one product was bought, and they generated lots and lots of sales for us. That's what we see. Okay? And even this is not an outlier because of the fact कि चलो इसके 5 चीजें खरीदी गई हैं, but the sales is 10,000. So this is probably just a pattern of sales that is occurring. Okay, so I can categorize all of this together, and these 3 I can categorize them separately. So the products are being bought in quantities from 1 to 5, basically from 1 to 3. So लोग जो चीजें ले रहे हैं वो 1 से 3 चीजों के दरमियान ले रहे हैं. That's the major part. But there's just one sales which has जिसकी 5 चीजें खरीदी गई हैं, maybe some wholesale scenario. But one thing is confusing, the why 0 here? How come I have 0? Gee, what does this mean? 0,0. Finish.
सर एरर है.
I think that this is the starting of the क्या कहते हैं,
एरर है कोई डेटा एरर.
हाँ एरर भी हो सकता है. Let me look at the data. I don't think I put any 0 sale here. हाँ नहीं, ये the missing values have been filled up with 0. That is the main point here. जो मैंने missing values fill किए ना, probably this is the row जो कि गड़बड़ कर रही है. या तो इस पे दोनों पे उसने 0 डाल दिया है through imputation, या इस दोनों पे 0 कर दिया, इन दोनों पे 0 कर दिया. बहरहाल that is what you will expect जब आप missing values impute करते हैं. That is what you will expect to happen. Okay. अच्छा, now what we do is that we find out those values in sales and quantity जहाँ पे null है, and we create those rows. I think ये 3-4 rows ही होंगी. Yeah, so we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. we have 10 rows in which I have either quantity missing or null missing. So let's cross check that. So 1, 2, 3, 4, 5, 6, 7, 8. I think we have 9. We have 10. So it's probably 9. I just probably got confused here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10. Okay. So what we are plotting here is now missing DF. We are plotting the scatter plot. I think it's the same as the above one, right? So nulls is the color. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6. I think we have some superimposition here. हाँ आप ये देखें, ये चीज आप देखने की, right? So I do the quantity here. Sorry for that. Yeah. Now what we need to compare, students, is that we have this chart in which this chart we drew when we have the missing values filled in, right? Is this thing clear, right? We filled up the missing values through the imputation, and then we draw this scatter plot. In this scatter plot, we are drawing the same scatter plot, but what we have done here is that the missing rows in which the data was missing, we have plotted them using the yellow color. We are plotting the same missing DF mean, but color we are coloring according to the null value. So these were the values in which the यहाँ पे तो 6 नजर आ रही हैं, उसमें नीचे होंगी वो सुपर इम्पोज हो गई होंगी पर्पल के ऊपर. So out of the 10 rows, I can see 6 rows in which I had null values, and the value replaced was this one जो कि हमारे सामने है. यानी there was no value here. These were the points which were actually null. Okay, these were the points which were null, and now the value is replaced for them. So what is the conclusion when you see this chart and this chart? Can you tell me the conclusion?
Hello? Yeah. So the conclusion would be that the average sales is around is 10,000, which is why all the null values have been converted to 10,000.
The main conclusion that you want to draw is that I let the algorithm fill up the missing values. Has it done it correctly? So if the algorithm has put in the missing values here, it seems that these missing values are close to the distribution of points which are actually there. Okay. So this means कि उसने कुछ काम सही कर दिया. It has done a good job. If it had, अगर ये जो values हैं, if they were like somewhere here after imputation, then we would be really worried that what is happening, man. I mean, I have some values here, I have some values here, but I have the missing values are being replaced by giving it here. So this means that something is wrong. Do you understand what I'm saying? मैं कहना ये चाह रहा हूँ कि जब missing values replace की जाती हैं, तो ये देखा जाता है कि वो sales की distribution को follow कर भी रही हैं कि नहीं कर रही. Do the filled up missing values follow the distribution of sales that I have, or it is doing something really strange? So in this case, as it has filled up the missing values between this outlier values and the normal trend values that you have, it seems that it has done a good job of filling up the missing values. Is this thing clear? Ji. जी
I think
हसीब मुनीर क्लियर हुई है बात आपको कि नहीं? जी नसीमुल्ला खान।
सर काफी हद तक क्लियर हो गई है।
ठीक है, नसीर अहमद।
Yes, sir, it's clear.
अच्छा चलें, वो सही है। अच्छा, अब हम यही काम अगर कस्टमर एज के साथ भी करके देख सकते हैं, वी कैन सी इट। सो आई विल जस्ट I have to plot the sales area. Sorry about that. I'll just it's just not done correctly. So you can see get the filled up values for with respect to the customer age. You know, it's again very close to the distribution of points which are already there. So it seems we are doing something which is good. And now we re-import the data again because we have messed up with that. So we can use this KNN imputer. In the above case, we were using the simple imputer, but now we can use the KNN imputer as well to impute the missing values. So in this case, we redraw the scatter plot. It has imputed, so I'll just do this rainbow thing. So I think the missing values are the red ones. Okay, sorry about that, sir. I got the quantity here. So it seems that you can see ke jo missing values, the values that have been filled up in by KNN imputer are different from the values that have been filled up by the simple imputer. The simple imputer has given the missing rows these 6 values or 5 values. You can see that their distribution is different, while the KNN imputer has given these values which are in red. So, and this is where actually applying the KNN formula for that. KNN is the K nearest neighbor approach. So इसमें approach ये होती है कि you look at your nearest neighbor, you look at the rows which are closest to you, and you fill up your missing values according to what is contained in that rows, in those rows. So for example, if this is your data frame, please listen carefully, and this row has some missing information. So we will see ke what is the row that is most similar to this row depending on the content of the row. So let's say that this row X is most similar to this row which contains some missing values. So I will use information from this row to actually fill up the missing values here. So K equals to 2 ka matlab hai ki I'm looking at the 2 rows which are most closest to this row. Okay. K equals to 5 ka matlab hai ki I am looking at those closest 5 rows. Okay. So let's see ke iska kya chakkar chalta hai. So if I do the same thing here. So when I say K equals to 5, you see the missing values are, you know, it seems that this is okay. I just have yeah, aap bhi kar lijiyega please. So for K equals to 5, the pattern goes like this, and K equals to 2, the pattern goes like this. And for the case of the simple imputer, the pattern goes like this. So it's basically the same thing. So this seems, I think, much better than the previous KNN imputation. Even I think this is okay. It's imputing. It's not doing something really. Do you see ke it is not doing something which is really strange. Otherwise, ये red points यहाँ पर होते, कोई red point यहाँ पर होता, कोई red point यहाँ पर होता, तो it would have been really strange to fill up. So it's filling up very in a good way. I don't know whether K equals to 2 is good or K equals to 5 is good. I think this is sort of risky because it is plotting you, it is giving you some values of quantities which are not already present. So here the quantity is 2.5, which is not good. Here also you can see the quantity is 2.5. I can't have 2.5 quantity. Here is also something which is so this problem persists. So I can just round that off. It's 2.5. I can put it equal to 3. So we don't know okay, what is the actual case, but you know, let us see with respect to the customer age. Oh, so this seems pretty good, right? Because it is concentrated in the normal way. आप ये भी कर सकते हैं कि you can just draw the box plot to understand कि how things are happening here. So ये box plot with the original one and the box plot of the new one, and see कि what difference to the box plot it has made. If you can do something like that, you can do that as an assignment. So any questions in here?
Yes, sir, I have a question.
जी.
Sir, those two things I think. One thing I want to know, in the beginning, in the data, we are clear that there's something like the quantity, there's a particular data point where the quantity is 0. Why didn't we convert the 0 initially into a none value and then impute it?
So देखें, you are probably talking about this point, right?
Yes, sir.
So in this case, I think this is a data entry error because we have a sale. So it should be, it can be either 1 or 2. So I think this is a data entry error.
So, sir, we can convert the 0 into a null value, and then the imputation that you were doing afterwards would automatically
we
also
should.
do this.
In fact, we should do it. I agree with you. I agree with your statement. We did
So
not
there's
do it
another
in this
question.
file, but you can try it out, you know.
Another question, sir. Sir, if we look at the customer IDs and the customer name, there's
Yeah.
chances that sometime the empty thing might be an ID which has been repeated somewhere else. So why didn't we check whether that is the case?
Yeah, actually, we'll just wait for the other 2 files, and then you get the answer, inshallah. We just come to this missing 2. It's a, you know, just let me explain it in this way. Okay, I told before also, by looking at the values in the other columns, I can try to determine the ID and also the customer name. But that is a risky business because that is my assumption. It might be true, it might not be true. But if you do it and you are confident about it, then you can do it. No one is going to stop you. You have to make sure that whatever wrangling you are doing does not have a very strong impact on the final analysis that we want. That is why we see the normal curve and we see the box plots and we draw the pivot tables and the group bys, because we don't want to do anything which is very strange. And this is the reason that we have plotted these kind of things, to really understand that what is happening, you know. We don't want the values, filled up values, to be very strange. As Binish has said, that this is something which is not good, so we should not be considering this value in our analysis. अब उसने कर दिया है तो चलो ठीक है, अब उसको हम okay, missing 2. So we know about this Bakar and Manar, etc. So in this case, we are going to use the same file, but we are going to use a different value. So this is the file which is there, and mano.var. So I just directly use the Missingno library. So in this case, you can see how many missing values are there in each column. So the most missing values, I think, are in customer age or maybe in sales. The customer age is 4, sales is 7, quantity is 6. So this just gives you, it just tells you how much column is missing basically. Na? So you can see the customer age, quantity, sales are quite missing, or baki thare thode se filled up hai, unki missing values kam hai. Then just apply the matrix function to understand it even better. So in this case, as we have only 28 rows, so we can, this is pretty understandable. Okay, missing values, where are they actually occurring? So they are occurring here, here we have 2 or 3 values missing. We have here in this date column, nothing is missing. So product bought, I have 3 instances missing. So because the data is so small, so it seems very good to monitor it in this way. So what can you conclude from this chart? Tayyab Khan. Waqas Badr. Zakir. Raza Bakir.
Remove, so we can remove customer ID because only one there it also has customer name not available there.
भाई इससे सबसे पहला कंक्लूजन तो ये है कि which column contains the most missing values? Which column contains? Tell me.
Sales.
Sales.
Sales and quantity. So we need to address these first. Okay? Because they are also our KPIs and we need to address these first. And here we can also see the pattern of missing values. ये जो side में आपको this you can see this broken line. It gets broken when there's a missing value. So here there's a lot of break because in this row I got actually 3 or 4 missing values here around here. This break. In this row I got 3 or 4 missing values. This is the break with respect to the row. Okay. So it depends how you see it. Acha, Mano has basically 3 or 4 functions. What is the Mano.bar? Mano.matrix, and then we have the Mano.heatmap. अब आप बताएं शाबाश, hurry up. How can you interpret this?
Basically the heat map, you know.
Yeah, please speak.
So basically the heat map shows a correlation between the various columns. For example, sales to customer ID. For example, customer name is like 0.7 with correlation to customer ID. So it just shows the various how much the data is sort of interlinked with the various columns.
No, yeah, it is a correlation, but it is the correlation between the patterns of missingness. So yeah, if you see here that the 0.7 between customer name and customer ID, so you can see that the pattern of missingness in this case is here and here, the pattern of missingness is almost the same. Do you see? Because they are occurring in the same column. In the same row, there's a very similar pattern. The size is also not very much different and the position is almost the same. You can what about 0.6 between customer ID and product bought? So customer ID and customer ID seems central between product bought. So that is 0.6. And 0.3 between quantity and sales. So it seems 0.3 because of the fact that it is okay. What about product bought and customer age? 0.5. You see, it's a good correlation because product bought, we have 3 bars here and we have 1 full here. So there's a high correlation, which is 0.5 or more probably. So why we are looking at this? Because we want to understand which columns have the pattern of missingness which are close to each other. Maybe we can fill them up in the same way together.
Good question.
Yeah.
Sir, the product brought, I think, is a data type of it's like an object, it's a string. Correlation with strings. So can we do correlation with strings and floats? Because correlation usually happens with numbers.
Yeah, it is not a correlation between actual correlation. It is a correlation between the missingness pattern, which is all numerical. जब आप mano.matrix करते हैं, sorry, mano.heatmap करते हैं, it is going to give you a correlation matrix between the pattern of missingness, not the actual values.
Oh, okay.
Please try to understand this. It is going to show me कि किन columns की missingness आपस में ज़्यादा correlated है. That is what it is going to show me. Which is the pattern of missingness which is most correlated. Okay, so let me just make it clear that no one can tell you what is a standard way of replacing missing values. We have seen the dropping of rows, the dropping of columns. We have seen filling up with mean. We have seen simple imputation. We have seen regression based imputation in the last class. We have seen KNN based imputation today. So there are lots and lots of ways, but आपने कौन सा method इस्तेमाल करना है, that depends on your analysis. So the Mano library, the Missingno library that we have here, is here to help you basically see that, you know, we are simply using this to help you understand things in a better way. The exact strategy that you will use is going to depend entirely on you. It is not going to depend on me. Neither I can teach you how to replace. It depends on you. You need to try out different things and see whether it is working for you or not. Okay. Okay. What we have here is the different charts that are here. Just wait, please. So the Missingno library is giving you several, you know, is giving you several charts to help you fill up the missing values. So first is the bar, then we have the metrics, then we have the heat map, and then we have the dendogram. So dendogram is also pretty useful. So dendogram is showing you basically ke when you have a simple line here, it means there are no missing values in serial number and date. And then it is telling you ke kahan par masla zyada aa raha hai, where the problem arises the most. So we have missing values in product bought, customer age, but now it is correlating them. Do you see the dendogram is actually the correlation is being shown in here. So customer ID and customer name, their missingness pattern is almost the same. You can combine this, but they don't have any missing values. And then the pattern of these two, which is coming here, is similar to the pattern of product bought, which we saw also above. So the pattern of customer ID and customer name is similar to the pattern of customer age. Or product bought. I think it's product bought or what? Yeah, product bought. And which is similar to the pattern of customer age. Okay. So the pattern of these two, sorry about that. Just in dono ka pattern is similar to this one, and the combined pattern is similar to this one. So the dendogram is building up step by step. Okay. And then iska pattern jo hai phir in the or sales or quantity ka pattern aapas mein similar hai. There's a lot of similarity between the pattern of sales and quantity. I think we'll see the heat map for that. Heat map is 0.3. It is still good, not very bad. And then obviously we can combine them. So this is the this is how you can see these 4 charts to help you to understand the to data, and then you determine the missing value strategy. I can drop the entire row from the whole data set. It will be like that. So it just drops everything. And obviously then I need to read the file again. I can just drop the customer name. Sorry about that. Sirf un rows ko delete kar dein which contain in which the customer name contains the missing values that we have done above as well. So in this case, customer name becomes 0 and the others are already there. So obviously some rows will be deleted. So I can also do the imputation that we have already seen. So I can impute with respect to the, you know, so here everything has been imputed with respect to the sales, with respect to the simple imputation. So imputation is going to work only for numerical columns in which we have the customer age, quantity, and sales. Other than that, we are not interested because these are the 3 we are more interested. These are the basically your KPIs, you can say. So still we are left with the product board. So let's draw the scatter plot. I think we should see the quantity first. So it's the same thing. C map equals to rainbow. So it's a rainbow map for quantity versus sales. So it's the same thing we did in the last file. So these are the same things that we did in the last file. So we can just repeat the same things here. So you just want to see whether it's doing it in a good way or not. So again, we do the same for the customer age. So we just have to make sure that, yeah, sales has to be basically. Yeah, so it's still the same thing. So now we can do the try the KNN imputation, which we already tried. So this is you can print it, and these contain the imputed values. And then again, so this is wrong, so I can just plot the quantity. So this is rainbow, then now we can try it from here again. Okay, so now this file has shown us some extra things that you can try out. You can, I will advise you to make your own template now. Just make your own notebook file in which you can try out all these wrangling functions that we have done today. We need to finish this as well, so let's try it. So we just the missing values are there, and here we have the different values. You can just read the missing values. We can just drop the rows. So uska code word dekh lein aap kis tarah hota hai customer name. I think it's the same thing here. Basically, these are the different methods you can have. This is very similar to the first file that we saw. So missing DF, I have missing DF mean. So product board. अच्छा, what strategy will we use to product board के लिए क्या strategy use करेंगे आप? All of these are the same things that we have already seen, It's just different ways of doing the same thing. Okay, if I ask you to impute using the values for product board, so let me just where is it? Missing value data. Now product board contains two missing values, right? One here, so no, we have not two but three. 1, 2, 3. Yeah. Yeah, we have three missing values. So can anyone tell me a strategy in which you will use to replace the product board missing values?
Sir, we can check quantities and sales for that.
Sorry?
Sir, sales quantity and sales value.
हाँ, तो इसमें आपको what you can do is that you can have this this pivot table.
We can calculate per unit cost or like somehow उसको फिर मैं आप impute कर दूँ कौन सी product की per unit cost match करती है जो missing है.
हाँ ठीक है, इसको करके देख लें तो ज़्यादा बेहतर होगा, ठीक है. So now one more thing is remaining for today. Let me just okay, so here is a file for rich people. Oh, I'm sorry, brother. Yeah, so this is a downloaded file of rich people and it contains lots and lots of data. It also contains some missing values, I guess. It contains something which needs to be really clean. So इस तरह का जो data है, this source 1, source 2, source 3, source 4, obviously we are never going to use such data in any type of analysis. You can simply just remove these rows. You know, ये notes में देखें आप, notes में कुछ values missing आ रही हैं. I don't know कि notes use होते हैं कि नहीं. GDP current status is completely empty. Political connections is just one. I don't know, one. So lots and lots of missing values in political connection. I don't know whether there are missing values in this other ones as well. 1654. Yeah, so everything else remains. Everything age is missing values hain, and I don't know about the other ones. So there are lots and lots of errors here. You know, we just I can't. So let's go back to this. Yeah. So I'll have to teach you this. आप ये काम करें कि अभी तो आपका काम ये होगा कि what you need to do as an assignment for the next class is that you need to take this. एक तो ये कि जो product board की make a separate template in which you take my missing data file and try to do different things on it based on what we have done today. Okay. Try to develop your own strategy because we have also dealt with some missing values in this date time analysis. I don't know whether we have dealt with this here or not. हाँ, date time analysis में तो missing value का हाँ, तो पहला तो काम ये हुआ कि missing value data के ऊपर the data which is missing, you just do the analysis of sales etc. जो कि मैंने आपको करके दिया, Dist plot, Boxplot. So this is pretty simple analysis, right? And then you develop your own strategy for missing out the value, filling out the missing values, including something to fill out the missing values of product board. So product board के लिए हम intelligently किस तरह missing values ला सकते हैं, वो जैसे बिनीश ने एक अच्छा solution बताया है. You can follow that or you can just you know develop your own strategy for that. एक तो ये काम करना है. दूसरा ये काम आपका है कि जो rich people की जो Excel file है which I was showing you. So do on this what we have done up to now. I mean, there are some KPI values. For example, I have this rank. Okay, year is not something which is I should looking for a normal distribution. That is wrong. I have this rank of the people. I have their net worth in US billion dollars, which is the most important variable. I have their age, so you can fill up the missing values and then analyze the age. And I think that's pretty much it. जो फजूल columns हैं, just delete the columns which are not of use to us. Okay, and try to fill up the missing values as much as possible in this file. And then I want the analysis of this rank and net worth in US billions with respect to the Dist plot and the box plot that we saw. Okay, so you need to submit me two notebooks, one for the missing data file and the one for the rich people file. Okay, that's what you need to submit before the next class.
So you're saying before the next class, yani tomorrow?
So the next class tomorrow. Yeah.
वो just one. Okay, for tomorrow you are going to get marks for your attendance. Tomorrow's session is purely a discussion between the students. So someone should take charge of the discussion. मैं आपको Zoom link भेज दूंगा. Take charge of discussion और आपस में discuss करके try to solve the problem within 3 hours and then submit it. 1.5 घंटा, just spend 1.5 hours on the first assignment, 1.5 hours on the second assignment. You have the code in front of you. It will be a good thing to discuss in real time and then do it rather than कि मैं अकेला बैठूंगा अगले हफ्ते आखिरी रात बैठूंगा मैं करके दूंगा. तो अगर आपस में discussion करेंगे ना, it's going to create a good learning environment. Okay, so that this is not an official class. Please keep this in mind. We are going to have 4 more classes after tomorrow's one, but tomorrow I'm not going to teach anything. Okay, I just want you guys to submit these 2 things tomorrow by 5 o'clock or by tomorrow night. सही है? चलें सही है. Okay then.
ठीक है, थैंक यू।
Okay, अस्सलाम वालेकुम।
Allah Hafiz.
अल्लाह हाफिज़।
Allah Hafiz.